Okay, now I'm going to do part B. I'll switch colors. I'll switch to blue. Okay, it says write but do not solve a differential equation for the instantaneous speed of the ball in terms of time t as the ball moves upwards. Okay, that shouldn't be too bad. Basically, this just means that they're, oh, differential, don't freak out about that. I think we already pretty much have this one done. Goes back to what I was saying. I probably should have just worked through all this, then went back and justified this, but whatever. You can do it in whatever order you want as long as you let them know where your work is. So anyway, let's look at this. So a differential equation. Oh, and they say that do not solve. Keep that in mind. For the instantaneous speed of the ball in terms of t as the ball moves upwards. That pretty much they want something that's going to have velocity in it, just to kind of show how your velocity changes. Just sorry, my dog's being weird. Anyway, they just want to see basically how velocity is going to change. You know what, I'm just going to work it. Let me show you. Okay, so we already can use on this what we already have here. Actually, this. That's kind of messy. But what I would do is I'd draw a circle around this if you'd used it to justify your stuff up here. And I would just, put it here. And basically what I've got is mass times acceleration equals, that should be a negative if it's not, because remember, positive's up, so you're going to want to specify that gravitational force is down. So you're going to have negative weight minus kV, which is your air resistance, right? So they want a differential equation. So where can you put, that means the, first, your derivative type thing. And they want it in terms of velocity. Well, first let's look at which one of these things you can break down. Well, hopefully you know that like the easiest thing and the first thing, really one of the only things we've gone over that is calculus like that you could do on this is your acceleration. So let's just break that down. So you'd have mass. Oh, and I've been really bad here. I'm not using their terms. So I need to use a capital M because that's what they're using for mass. Now, acceleration. Acceleration is dv dt, which also I know breaks down into the second derivative of position with respect to time. But if they were asking for position, then that's what you would use. You would just break this down to position. But you're not. This is all they need. dv dt. Notice they said don't solve it, so we can just plug this in there, and that's going to equal negative, oops, that's a capital M, mg minus kv. So that should be good. Now, notice I did not put the V naught. Here's why. I know some of you are like, oh, wow, she made a really big deal about putting it in these things, but she didn't there. Here's why I didn't. Hey, guess what? That says differential. That's calculus. So V naught, see up here, it says express all algebraic answers, V naught. Now let's think about it. V naught is your initial speed. When you have calculus, that is like saying it varies. It varies a lot. We need calculus because it varies so much. So it would be kind of weird to put V naught there because that's just one thing, and that one thing is presumably fixed. And, your initial velocity is your initial velocity. It's not going to change. So it would be inappropriate to put it in a calculus differential equation thing. So watch that too. They're trying to trick you into putting V naught because they're evil like that. But you guys should know that.